Hi everyone, welcome to Lecture 5A on Basic Inorganic Chemistry. My name is Dr. Teresa Chimambam. For today's lecture, we will cover isotopes and chemical formula. What are isotopes? Isotopes are atoms of the same element possessing same number of protons but different number of neutrons. What this means is that isotopes are atoms of the same element that have the same atomic number but different mass number. So all isotopes have the same atomic number but different mass number. So what this means is that each isotope has a different number of neutrons. Let's look at some examples. Isotopes of carbon. The isotopes of carbon are carbon-12, carbon-13, and carbon-14. So the atomic number is always the same, 6 here, 6 here, 6 here. So that's why they are called isotopes of carbon, because they have the same atomic number but different mass numbers. So if you look at carbon-12, the number of neutrons will simply be 12 minus 6, which is 6 neutrons. So carbon has 6 neutrons. It also has 6 protons and it also has 6 electrons. Remember, number of protons must be equal to number of electrons. And here, carbon-13 has 17 neutrons. So 13 minus 6 is equal to 7. It has 6 protons and it has 6 electrons. And carbon-14 has 8 neutrons, it has 6 protons, and it has 6 electrons. So isotopes always have same atomic number but different number of neutrons, as you can see in this example. Another example is isotopes of chlorine. So one isotope is chlorine-35 and chlorine-37. So each has atomic number of 17. So that's why they are isotopes. They have the same atomic number but different mass number. So chlorine-35 has 18 neutrons. So 35 minus 17 is 18. It has 17 protons and it has 17 electrons. Chlorine-37 has 20 neutrons. 37 minus 17 is equal to 20. It has 17 protons and it has 17 electrons. So isotopes always have same atomic number but different number of neutrons. So let's have a look on isotopes of hydrogen. So hydrogen has hydrogen 1, hydrogen 2, and hydrogen 3 isotopes. So hydrogen 1 has 0 neutron because 1 minus 1 is equal to 0. It has 1 proton and it has 1 electron. Hydrogen 2 isotope has 1 neutron, 2 minus 1 equal to 1. It has 1 proton and it has 1 electron. Hydrogen 3 has 2 neutrons, 1 proton, and 1 electron. So you notice that always the number of neutrons for each of the isotopes are always different, but the number of protons, which is also called the atomic number, is always the same. Other elements that exist as isotopes in nature are nitrogen. Nitrogen can exist as nitrogen-14 or as nitrogen-15. Oxygen can exist as oxygen-16 and oxygen-18. Bromine can exist as bromine-79 and bromine-81. So you notice in each case, the atomic numbers are always the same. Only the mass numbers are different. So now we look at chemical bond. What is a chemical bond? A chemical bond is a single, double, or triple bond that joins two or more atoms in molecules or compounds. So this means that a chemical bond can be a single bond, it can be double, or it can be triple bond. So for example, in methane has single bonds. So single bond joins each carbon and hydrogen together. So this is what we call a single bond. This is another single bond. This is another single bond. And this is another single bond. So methane, for instance, has triple bond. You can see a triple bond joins two atoms together. And carbon dioxide has double bond. You see double bond between carbon and oxygen, and another double bond between carbon and oxygen. So a chemical bond joins two or more atoms in molecules or compounds. And chemical bonds can be single, it can be double, and it can be triple, as we have seen in these examples. And also, a bond always forms a lasting attraction between the atoms, ions, or molecules, giving rise to chemical bonds. So a bond will always form a lasting attraction between the atoms, and this is what gives rise to chemical compounds. So now we look at chemical formula or molecular formula. So a chemical formula tells us the number of atoms of each element in a compound. So a chemical formula shows the symbol of the atoms of each element present in a compound. It shows the number of each element in form of subscripts. So let's have a look on these examples. So methane, for instance, has a molecular formula of CH4. So this subscript shows that there are 4 hydrogen atoms. Water has a molecular formula of H2O. So this too shows that there are 2 hydrogen atoms in water molecule. Glucose has a molecular formula C6H12O6. So this 6 shows that there are 6 oxygen atoms. This 12 shows there are 12 hydrogen atoms. And this 6 here shows there are 6 carbon atoms. Ethanol has this molecular formula. So it has 6 carbon, 5 hydrogen, 1 oxygen, and 1 hydrogen. Benzene has 6 carbon atoms and 6 hydrogen atoms. So chemical formula or molecular formula shows us the chemical symbol of elements that are present in a compound, and it also uses subscripts to show the number of each element in that particular compound. So this is where I'm gonna end today's video. Please like this video and subscribe, and I will see you in the next lecture.